Now in the previous lecture we have learned what grid algorithm is. Now in this lecture we will go through the grid algorithms that we have learned throughout this course, and we will show you why they are grid algorithms. So these are insertion sort, selection sort, topological sort, and Prim's algorithm and Kruskov's algorithm. Now the first one is insertion sort. Now let's quickly recap what we have done in insertion sort. So here we have an array like this, and we have to sort this using insertion sort. So the first thing that we are going to do over here, we divide this array into two parts, which are sorted and unsorted array. Then from the unsorted array, we take the first element and put it in its perfect location in sorted array. So after few iterations, this is what our array look like. So till this part, the array is fully sorted, and in the right part, the array still is unsorted. So in the next step, we will take the first element, which is 6 in our case, from the unsorted array, and we will put it in its perfect location in sorted array. Now in this case, it will be between 5 and 7. So if we closely observe this step over here, we can see that it follows greedy choice, as it aims to find local optimum solution at each step. So in our case, the local solution is this sorted array over here. So by putting these elements in its perfect location, we kept our local solution as optimum. So at the end, this local solution leads us to optimum global solution. So in each step we are finding the best local solution for these elements, and then all these local solutions leads to global solution. So this is why insertion sort algorithm is grid algorithm, as it follows greedy approach when sorting elements of array. Now let's continue to the next algorithm. The next algorithm is selection sort. Again, in case of selection sort, we divide the array into two parts, which are sorted and unsorted. And in each iteration, we are finding the minimum element from unsorted array and put it its location in sorted array. Then after few iterations, our array will look like this. So in this case, on the left side, you see that the array is fully sorted, and on the right side, the array is still unsorted. So at the next step, we will find the minimum element, which is 5 in our case, and put it in its perfect location in sorted array. So as you see here also, in each step, we are finding local optimum solution for sorted array. Then after finding all local optimum solution, it will lead us to global solution. So this approach is called greedy approach. So that's why this algorithm is also greedy algorithm. Now the next example of greedy algorithm is topological sort. Now in case we have given a graph and we want to do topological sort on it, if we closely observe topological sort, we can see that we take each node one by one and check if this fulfill the criteria of greedy choice, which means if the node does not lead to the local optimum solution, we defer their push operation in the stack. Now let's say if we start from the C, we see that this is not the best local solution in this case, because in this case E depends on C. Then that's why we are deferring C and we are continuing to E. Now when we reach the E, we see that this is also not the local optimum solution, because in this case H is depend on E. So that's why E is not the best solution in this case. Then we are continuing to H. Now here we see that there is not any element that depends on H. So this means that in this step, H is the best solution. So if we find the best solution, we are pushing this best solution to the stack. Now after pushing it, we can continue to the parent of H. The parent of H is E. So this means that this is the local optimum solution now. So we will push E over here. Then we are continuing to the C, and we are pushing C to the stack, because in this case, at this stage, C is the local solution. So that's why we are pushing C over here. Then we are continuing to A, and in this case, A is the local optimum solution. Now, if you pop up these elements from the stack, our answer will be A, C, E, H. So you see that we have got a global solution using local solutions together. So here, at each step, we check if the elements leads to the local solution, then we take it. Otherwise, we are ignoring it. Now let's continue to the next example of grid algorithm, which is Prim's algorithm. So in Prim's algorithm, we are given a weighted undirected graph, and we need to find a minimum spanning tree. So what we are doing over here is, we start from any vertex and explore the graph. While exploring the graph, we check that if there is a way to minimize the distance between vertices. Now let's say we have a graph like this and we start from the A. Now as a first step, we are setting A to 0 and all other nodes to infinity. Then we are finding the distance between A and their adjacent vertices. So in our case we have B and C. So from A to B it will take 10 and from A to C it will take 20. Now in our case the local optimum solution will be B. Because B's cost is less than 20, so in this case this is the minimum. So we have found that B is the local optimum solution in this case. Then from B we will calculate the cost of adjacent vertices C and D. So in this case C has better cost, so we will not update it, and D is infinity, so this means that we will update it to 5. So in this case 5 is minimum, so this means that this is the local optimum solution in this case. So we will continue to the D. Then it will continue like this, so we are continuing then to E, because E is the local optimum solution. Then we are continuing to C. C is the local optimum solution. Now if you combine these all local optimum solutions, we will get global solution like this. Now here you see that by combining all local best solutions, we can find global solution. So this is greedy approach, so that's why Prim's algorithm is called greedy algorithm. Now we are continuing to the next algorithm. So the next algorithm is Kruskal algorithm. So here again, we are giving weighted undirected graph and we need to find minimum spanning tree. So in case of Kruskal algorithm, we take the best edge in each step. So if the edge creates a cycle, we ignore it, otherwise we take it. In each step, by taking the best edge, we are finding local optimum solution. Now if you look at this graph over here, so if we try to use Kruskal algorithm to find minimum spanning tree over here, the first thing that we are going to do, we will select minimum edge. So in our case, the minimum edge is between A and B, which is 5. Then we will continue to define the next minimum edge. So the next minimum edge is between C and D. So this is local optimum solution in this case. Then we are continuing to the next minimum edge, and in each case, we are checking that if this edge is not causing cycle. Now the next edge is BD, which is 8. Now in this case, this is the local optimum solution, so it doesn't cause any cycle. Then we are continuing to the next edge. Then now the next edge is 10, which is between D and B, but if you put it over here, we see that it causes cycle, so we are ignoring it, and it will continue like this, and our final solution will be like this. Now if you observe these steps very clearly over here, we can see that in each step, we are finding local optimum solution, and then at the end, we are joining all these local optimum solutions to find global solution. So this is greedy approach, so that's why Kruskal algorithm is called greedy algorithm. So these are the algorithms that we have learned in our previous lecture. Here I've just shown you why we are calling these algorithms greedy algorithm, because here we are making greedy choice. Now in the next lecture we will look at another problem, which is activity selection problem, and it's obvious that this problem will be solved using greedy approach. So see you in the next lecture.